Hi students, in this video we're going to talk about function operations and composition. Alright, first thing we got to take a look at is function notation in general, just kind of being careful with what these things mean. If I'm talking about f of 2, that's asking me what is the height when x equals 2. I've got two potential options there. Hopefully we know that the closed-in circle is the one that we look to for the actual value, so that's going to be -4. What about something like find a value such that f of a is equal to 0? So this means that the height of our function is 0, and that what we're looking for are x values that make this true. There are going to be two of them here. One of them is going to be at x equals -1, and the other is going to be at x equals 4. Both of those places I have a height of 0. And then finally, what about, I just accidentally switched to eraser. What about f of 5? So that should be this point here, but we have a hole there. We say this point does not exist or is undefined, or you can't do that because there's a hole in that graph. Any of those things would be okay things to say. Usually we use DNE for does not exist. All right, we've got a couple of graphs here, and what we're going to do is find some ways to combine them. So the first thing I'm going to combine, let's find f plus g of, I don't know, let's go with -2. What that really means is that we're finding f of -2 plus g of -2. When I do this, I'm going to find f of -2, which is 7, g of -2, which is 0, that's helpful, and I get 7 as an answer. The thing we have to be really careful about is not thinking that this is multiplication. This is adding two functions together and then plugging in the number. What if I did something crazy like 2f of 3 minus 7g of 2 squared? The problem here is I didn't make sure these numbers actually worked, and f of 3 definitely is not something we can see. Let's go with f of 1, because that will actually be pretty easy to find. All right, so we have -2. So 2 times -2 minus 7 g of 2, that's easy to see, -4 squared. I'm going to go with -4 minus 7 times 16, which is going to be 70 plus 42 is 112. So -4 minus 112 is -116. The last type of thing I want us to talk about here is dealing with composition. So again, this should harken back to Algebra 2. We're looking at things like f of g of do something that would actually work, -3. What this is asking us to do is to go into this function, find g of 3, and then whatever answer we get, we're going to plug this back into the function f. So g of -3, we have a value of 1. So this is really looking for us to find out what f of 1 is, where the answer is -2. Composition is all about plugging things in. And I can do something really crazy like f of 1. It's going to end up kind of gross in this particular problem because of this function, but we have the ability to kind of play with things in that way. We also don't need to just deal with graphs or just deal with equations. We can mix some of those up together. Here's an example where I have all three. What if I wanted to find something like f over g of, I don't know, let's go with 4. What that would really mean is f of 4 over g of 4. f of 4 is 5 from the observation on the graph. G of 4 is 12, and I'd be done. The other thing that I can do is do something like, this is going to end really badly if I'm not careful. Let's go with h of g of 2. So I know that I've got to find the inside first, and when I evaluate g of 2, I get 8 as an answer. That's asking me to find h of 8, which if I plug that in, we get negative 8 squared minus 2 times 8 plus 27. 8 squared is 64. That's going to be negative 64 minus 16 plus 27. Minus 80 plus 27 is going to be negative 53 as our final answer. This just kind of was designed to show you that you don't necessarily need to all be in the same format in terms of what we're looking for. We've got equations and graphs and tables that we can interchange and use to solve problems together.